Hello, Precalculus student. This video is for chapter 1.1. Part 2 is for function notation. So we talk about what is a function. Now we want to look at details on how to write a function out. The way we write a function is if we want to say height is a function of age, that means we want to predict heights by age. So the way we write it would be a formula or a function of age as age where age is the input, the one that you say of something, that is the input, and whatever that you want to calculate for prediction, that is your output. And we write it as f of something, f and then a parenthesis. Now, in algebra, a parenthesis means multiplication, but this is a function notation. It does not mean multiplication. So remember, f of x does not mean multiplication. Y equal to f of x would imply you're defining a name of a function called f, and then you read it as y equal to f of x. X is the input and y is the output. And then we would say this is a function of y, this is a function f, y as a function of x. So let's look at a different way of representing function and then use the function notation. And if I have a table like this, x, y, this obviously is a function because every x has only one y. If I say f of 2, that means I want to use this function and tell the output when the input is 2. So when the input x is 2, what is the output? Is 6. So I'll say f of 2 equal to 6. So basically you read off x from here. So anything that is after the function name in the parenthesis, that's x. And so in this case, x is equal to 2. You look up x equal to 2, the y, corresponding y maps to 6. So you say f of 2 equal to 6. Now, we can also find it the other way around to say, find x such that f of x is equal to 1. So that means I don't know what x is, but f of x. So that means this is y. Y is 1. So here, I have a y equal to 1. What is x? So my x would be, if you look at the table, is x is equal to 8. Okay. Question example 2 is we have a graph as a function. We want to find f of -4. So that means your x is equal to -4. And also in your graph, you would have a point of -4 and you want to find out what is y, right? Because in the graph notation, the y component in the graph, on the line, is the y value. That's related by the function. So let's look at, okay, so we have -1, -2, -3, -4. -4 is here. So this is the point with an x equal to -4, and we see that it is -1, so we say -1. So what you do is you go to x equal to -4 and go up or down, because there should only be one point that is on the graph. Find f of 0. That means you go x is equal to 0 and you go up and down. So x is equal to 0 here, up and down. Oh, it intersect here. So this is 0, 2. So that means it's equal to 2. X, y, x, y. It corresponds to 0, 2. This corresponds to -4, -1. And so you would say x is equal to -1. Now the other way around is find x such that f of x equal to 1. Now you notice that I say all x because you can have multiple x that has the same y of 1. So y is equal to 1. So y is equal to 1 is here, right? So here. And I don't look up and down, I look sideways because all these would have the same y of equal to 1. So I end up touching 2 points, actually 3 points. So if I go here, that's 3 points. So this is -2. So I would say x is equal to -2. It also touch x equal to 3. It also touch x equal to, what is it? 1, 2, 3, 4, 5, 6, equal to 6. So there's 3x. They all have a y equal to 1. If y is given, you want to find x, you go to the y value, look sideways. Okay. So the third example is when your function is given as a formula and we want to find f of something. We want to find the output. So so the first is my f of x is negative x squared plus x. I want to find f of negative 3. That means I want to plug in negative 3 in all the x notation, all the x in the formula. So whenever I see x, I will plug in negative 3. Negative is outside, is negative 3 squared plus negative 3. Remember, we have to do exponent first, so negative 3. So don't do negative negative here because you have an exponent. Unless there is no exponent, then you can. Negative 3 squared is positive 9, so it becomes negative 9 minus 3 is negative 12. Okay, box it. Negative of f of a. So negative is outside of the function, so I'll just put a negative 1. Then I'm going to do f of a. So that means whenever I see x, I just plug in a. So negative a squared plus a, right? The negative is outside, so I would put in here. Now distribute it in here, so it become a squared minus a. Okay, so you can plug in a variable. The third one is you will plug in a variable that is consists of two variables. So whenever you see x, you just plug in a plus h. So it become negative of a plus h. It's a square because it's a square plus a plus h. So that would equal to what? Negative of a plus x squared is a squared plus 2ah plus h squared because of foiling, right? Plus a and then plus h. There are no like terms here, so you just distribute this out is negative a squared minus 2ah minus h squared minus a minus h. The last thing we want to do is solve for x. I didn't put a space here, so maybe I'll do it here. Find x such that f of x is equal to 2. That means I know y and I want to find x. So that means I want to do 2y equal to, right? F of x is equal to 2. 2 is equal to negative x squared plus x. I want to solve this. So this is a quadratic. I'm going to move, do I have enough space? Let's move down here a little bit. Maybe I'll use some space here. So this is a quadratic equation. So it become x squared, plus x squared minus x plus 2 is equal to 0. So you have to move everything on one side and try to factor. So because this is a 1x squared, I can just factor by diamond. Plus 2, is it factorable? It's not factorable. Minus x squared minus x plus 2. Oh, I think this is not factorable. So maybe I'll just change this to negative 2. If this is negative 2, it is factorable. So let me change this to negative 2. Okay. So I want to find two numbers when they multiply, they're negative 2. When they add, they are negative 1. So it will be negative 2 times 1. So x minus 2, x plus 1. I'll change the lecture notes to negative 2. So then you solve it by x equal to 2 and x equal to negative 1. So that's the two answers. So when x is equal to 2 and x equal to negative 1, your output would be 2. So solving for x would be you put the y on this side and you put the y value on this side and you just solve for x. Okay, the second set is square root of 12 plus x. I want to find f of negative 3. That means x is equal to negative 3. So just put 12 minus 3. That is square root of 9. So equal to 9 is 3. Negative of f of a. That means I want a negative 1 outside times square root of 12 plus a. And that's it. There is no simplification. You can multiply it in. So it will be negative of square root of 12 plus a. And that's it. We can do a square root of 12 plus a. What about f of a plus h? So that would be 12 plus that is x, right? X is a plus h, and that's it. Okay, no simplification. Example 4, so we want to find f of -3. F of -3. So that means I plug in -3. So it'll be -2 times -3 squared plus -3 minus 3. So this would be, again, square first. So -2 times 9 minus 3 minus 3. Oh, -18 minus 3 minus 3. So it's -20. 24. We might. mm, Oh, this is a g, so this should be a g of -3. It's a typo. I meant to say g, otherwise it's a different, yeah. So what about x plus 2? So my g of x is -2x squared plus x minus 3. What is x plus 2? Now this is a little tricky because x plus 2 is the whole input. So what you should do is plug in -2. Whenever you see x, you plug in x plus 2 and then square plus, oh, I see x, I plug in x plus 2 minus 3. So don't just put, oh, it is -x squared plus x minus 3 plus 2. It's not. You have to, whenever you encounter x in the input, you just put in x plus 2. Now, x plus 2 squared, you have to FOIL. You cannot just do x squared plus 4. So it turns out to be, after you FOIL it, it's x squared plus 4x plus 4. Foiling means you have to do x plus 2, right? Just like when you do a plus h, you have to FOIL. And then we do plus x plus 2 minus 3. Now, let's combine like term, -2x squared minus 8x minus 8 plus x plus 2 minus 3. So it turns out to be -2x squared minus 7x. What about all those numbers? Minus 8 plus 2, and then minus 3, so it'll be minus 9. Okay, so that is the final answer. So this is just pay attention to if you have two numbers or two variable, one variable, one constant in the input. So basically, the x in the formula is a placeholder. Now the next things that we want to do function notation is something called difference quotient. So this shows up a lot in calculus. So this is a pre-calculus class. So we want to get you ready for evaluating this. So if I have h of x, oh my gosh, I should say f of x. Otherwise, this should be f. Yeah, this is all f. Otherwise, it's not right. Okay, so I want to do f of x plus h minus f of x over h. It's a very complex thing, and you can see that there's two types of function notation. Now, this one is easy to do because it's just the formula itself, right? But this will involve plugging in x plus h in the input. So let's do it to x plus h square plus 1. So that is this part, right? And then I minus the function. Remember to parenthesis it. And then I divide by h. And then the second part is simplifying. So x plus h, you have to do FOILing. X squared plus 2xh plus h squared plus 1 minus 2x squared distribute property minus 1 over h, right? So so do another one. So that would equal to 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1. So minus 1 plus 1 cancel, 2x squared, 2x squared cancel, all of this over h. And then so the last things you have left over would be 4xh plus 2h squared over h. Now notice that you can factor the h out, so be the h and h would cancel with h 4x plus 2h over h. Now you can cancel this, and the final answer is 4x plus 2h. That's the answer.